How many terms does x squared plus 4x plus 4 raised to the power 2001 contain? How many terms? So it's very simple. If you could remember, if for any binary form, the number of terms is always n plus 1. So number of terms is always what? M plus 1. If you checked, if you remember, if you have a plus b raised to the power 2, if you expand this, you get a squared plus 2ab plus b squared, which is how many terms? 1, 2, 3. So from there you can see it's 2 plus 1, which is 3. So but from this question, before we solve, we need to be careful. If this is not a binomial expansion here, this is not a binomial because this is 1, 2, 3, 3. So we need to convert it. So meaning that the first thing we do, we can write x squared plus 4s plus 4 as x plus 2 all squared after raised to the power 201. Do you get the logic? Because x plus 2 squared is this, x squared plus 4s plus 4. So using our laws of indices, this is x plus 2. 2 times 201 is 402. We can now use our formula to solve this. Our n is 402. Therefore, the number of terms here is 402 plus 1, which is 403. So the answer is 403. So remember, whenever you ask to find the number of terms of a binomial expansion, just add plus 1 to the index, that's the power. So the next question we ask the 8th term in the expansion of this. If you could remember, for any binomial of this form, the r plus 1 term is always n combination r a n minus r b r. That's the formula. So we are looking for the 8th term. 8th term. So 8 is 7 plus 1. So our r is 7. So our n is 11. Our a is 1 over x squared, and our b is minus x. So which is n is 11 combination 7. Y a is 1 over x squared raised to power 11 minus 7 and minus x raised to power 7. So which is 11 combination, that is 11 factorial over 11 minus 7 is 4. So 4 factorial 7 factorial from our combination. Why this 11 minus 7 is 4? So we have x minus 8. You know why? Minus laws of indices. So minus 2 times 4 is minus 8. Why this is minus x? And you can write minus x raised to power minus 1 raised to power 7 and x raised to power 7 using laws of indices. I did it so that we can combine this with the same base, x and x. So which is minus, because minus 1 raised to power 7 is minus. So minus 11 factorial. So we have 11 factorial is 11 times 10 times 9 times 8 times 7 factorial. So that's 7 factorial. We'll cancel out this. So remaining 4 times 3 times 2 times 1. No need of writing 1. Y minus 8 plus 7 is minus 1. So our answer is we have 4 in 8, 2, that's 8, 8, 8, 3, 3. So 11 times that, so minus 330 x raised to power. So that's our 8th term. The answer is B. So the next question. The next question, we are asked the term independent of s in the expansion. Independent of s means that's the constant term. And constant term means x raised to power 0. That's it. It's a constant. Must be because a constant term. So here, our a, first of all, we don't know the particular term. Using our formula, using our r plus 1's formula, which is n combination r, a, n minus r, b, r. That's for the expansion a plus b raised to power n. Our nth term is that. So our n here is 6, our a is x, so we are saying that r plus 1's term, because we don't know the particular term, so we need to get it. We need to find r before we now solve. So our n is 6. We don't know r, but our a is x, 6 minus r, yb is minus 1 over 2 x squared raised to power r. So let's expand some of these. This 6 combination r, y is x 6 minus r, y here, you can split this as minus 1 over 2 raised to power r using laws of indices, and 1 over times 1 over x squared raised to power r, which is the same thing as x minus 2 raised to power r. I used laws of indices. So minus 1 over 2 raised to power r times 1 over x squared. Minus 1 over 2 x squared is the same thing as minus 1 over 2 times 1 over x squared. And 1 over x squared is the same thing as x raised to power minus 2. So that's why I splitted it this way. So the next thing is let's continue expanding. Let's simplify. So here, we can bring this one forward, minus 1 over 2 r. Maybe we need to get the value of r. 6 combination r, x. Here, x is here, x is here. Remember, that's if you multiply. So what we have in here is 6 minus r minus 2 r, using laws of indices, which is minus 1 over 2 r, 6 combination r, x raised to power 6 minus 3r. So this is where the main thing comes. Remember, we are asked the term independent of x, meaning x is raised to power 0 now. Yes, for it to be a constant. So which implies that for this to be a constant, 6 minus 3r must be 0. That's the only way we can get the constant term. There is no x again. So which implies, therefore, making r the subject of formula, r is 2. So our r is 2. That's it. Our r is 2. So we solve. So substituting, therefore, we now substitute r as 2. So minus 1 over 2 raised to power 2. 6 combination 2. Putting in 2 here makes it a constant, so we don't need it again. So the answer is this raised to power 2, which is 1 over 4 times 6 combination 2 is 6 factorial over 6 minus 2, 4 factorial, 2 factorial, which is 1 over 4 times 6 factorial, 6 times 5 times 4 factorial, so over 2. So our answer is 15 over 2, 3, so 15 over 4. So our answer is 15 over 4. So the answer is A. So the next question, so that's how you solve this kind of question. We solve as if we don't know the value of r to get a reasonable expression before we now find r, depending on the equation. Okay, the next one, we ask which term has the greatest coefficient. If you could remember, I told you the greatest coefficient is always the coefficient of the middle term. The middle term is always the one that has the greatest. Middle term always has the greatest coefficient, if you could remember. So, and here, this is 200, and it will have 201 term. Do Do you get the logic? 201 term. The expression, if you expand it, you get 201 term, meaning the greatest is the middle, and the middle is now 101. Yes. So the answer is B. Because the middle of this must be 101. That's 100, 201 term, 100, 100. So the middle term will coincide, so it will be 101. So the answer is B. The next question, we are asked to find the coefficient of y cube in the solution, in the expansion. Looking at this is three terms. It's not a binomial, so but we use our common sense. We can write x plus y plus z raised to power 5 as y plus x plus z, taking x plus z as one term. Yes, we are correct. So we now use our expansion here. Remember, we are looking for the coefficient of y cube. So let's expand it from our r plus 1 term, which is n combination r a n minus r b r. So here our n is 5, so 5 combination r. Our a is y, so y raised to power what? 5 minus r. Y, this is x plus z raised to power r. So here the only way we can get 3 is if r is 2. Check it. If we make r equal to 2, we have 5 minus 2, which is 3. So whatever that is remaining is the coefficient. So when r is 2 now, implies that the coefficient is now the remaining, which is 5 combination 2 x plus z raised to power 2. So which is 5 combination 2, 5 factorial over 3 factorial 2 factorial x plus z raised to power 2. So 5 times 4 over 2, which is 10. So the answer is 10x plus z raised to power 2. So our answer is B.